是这个是他自己做的。出来呀，那个 app 来做。哦。
你要 download the past paper first. The latest one.
The copy register one.
The latest one is the latest one is the one you did yesterday.
No. Hey, what's the course code again? 2102. Yeah. What am I doing? Hey, there's only one paper. Oh, yeah, correct. Okay.
Oh, 2223 semester 2 right?
这个我还是不明白，也是不明白，不想啊。
2223
哇你
Wait, why the...
You should look at this.
Why it cut off? What is this?
Oh, you know.
need to set one goal I think.
Wow. Nuggets.
商业的这个定
I use my mouse.
Yeah man.
哦，不是不要靠的。NTU learn 它 post 的，最近有 post actually。
This one. Oh, there we go. Perfect. Okay.
你在演现在我在洗洗。
Okay, let's take a look at this question. Let's get started already. Okay, so now we have how many sources? 1, 2, 3, 4, 5, right? So we do one by one lah. Can. Ready?
Yes.
Can ah.
Ready. 看这个。哎，我在这，我在这。
Okay, we do V1 first, V1. So how to start with V1?
Ground V2.
Yeah, so ground V2 is 0 volts. Okay, so I think we can find what's the voltage here, right? Should be quite easy, right? Right. So this voltage is actually just V1 multiplied by R3 over R2 plus R3. Okay, we are doing V1 first. Wait, I wrote wrongly. Like that. Correct. Correct, right? Agree, right? Easy, right? This is the first part I haven't finished. This one you should get it immediately. No. You can ignore this one because we're just finding the voltage here. Because there's no current. I plus equals to 0. Got covered, yeah. And then you can go faster, right? Okay, so do I need to cover this? Okay. Okay, so we got this voltage. Okay, so this voltage is actually the same, right? The same here, correct? Here, right? Because I minus equals 0, right? 0 amp. Okay, so what happens is once we have this, right, we just need to find the current that's going right? We just want to know what is the current going down here. Okay, so with this voltage, we just divide by the whole thing lah. So the answer is actually R10, right, parallel with, right, R9 plus, okay, R8 parallel with R7 plus, wait, sorry, R7, just R7 only. Like that,
Huh?
this is the current lah.
Okay.
You just divide by this one. This is the resistance ma. The resistance here like that. You can see that what?
Oh yeah, I want to look at you cannot man.
So small and bigger.
Where's R6?
Don't need R6 ma. First I'm doing the V1 first. Like that.
Yeah. 我不是佛好吗？
You're doing a V2 is it?
Yeah, as in I'm just doing, I starting with V1 first.
What is V1? Oh,
Mm.
I'm like damn confused. I went to where am I now? I find. I don't try to explore this thing already. Because I graduated
You can always find it.
Oh,
Year 2 bro.
oh,
Let's see, you can't
next
teach
sem ah.
Next year. This one next year.
Oh.
Not even SN.
Okay, you can always take it next sem what. It's in a year 2 mod.
I know everything is year 2 more. But I haven't cleared it yet, so I rather clear it first.
Can you see?
I think I did wrongly. I'm supposed to R11 plus everything else. Yeah, so actually it's just this lah, just 1 plus R11 over the entire thing.
Some for me damn long.
Like that. Okay, then to find the on top one, it's just VZ, right? Multiply by, I need to R13, also just 1 plus, right? R13, right? Let me see. Just write out first bar. Parallel with everything else.
No, the 1 plus is equals to plus 1 is equals to
Yeah, because of this. Let me see. No pointer. Okay. Because of this one, this term, right, plus R11 ma, divide by this one. Yeah. That's why it's 1 plus. I think this one on top is the same also. Is this term plus everything below. Yeah, the voltage. Right, then divide by R12 parallel by blah blah blah. So the full thing would be just this one. Okay. This thing here first, like that. Bracket. Right, 1 plus R13 divided by R12. Right, parallel with. Okay, let me load the thing. Okay, R12 parallel with R11. So manage to get this. The term on top, this one, this term on top. Manage to get that one. It's the same thing, the this one, right? The left side, this one plus this one, right? On top, the whole thing, yeah. This one, yeah, is on top. I just simplify it lah. Yeah. Yeah, no, by the time exam over already. Faster. Oh, you got it already, right? Oh, okay. So you cheat. So is it correct?
Yeah,
Correct, right? Okay. Can go on next one, right? We have another 4 more sources. Maybe the people watching the recording, they'll be wondering. Yeah, they'll be wondering why so long. Why the recording takes so long. Can do it or not? Still start. Oh no. Okay, this one I bring down first, bring somewhere first. So we got V1 already. Okay, then we try another one, V2. Maybe V2 V2. Okay, so if V1 is 0, so here is 0 volt, right? Immediately. No current everywhere. So here is 0 volt. Okay, and since there's no current here, here is 0 volt. Right, we should be able to see this immediately. Okay, so here and here is 0 volt, so we can ignore this R10. Right, it's open circuit. No current go through also. Right, or it's short circuit or whatever lah. Okay. Now we just need to see what is the current going into here. Right, how to find that? Okay, so we need to do some current divider, right? Right, because current go through here, by split, go down here, correct? Yeah, but actually you can ignore this one because the voltage here is still the same as here, right? So we can ignore R6. So we just take, in this case, we calculate the total current through here first, right? To R7, through R7 first. So what we do is V2 divide by R7 plus R8 parallel R9, like that. Okay, so it's V2 multiplied by this one. Okay, and then we want to obtain the current through R9, right? Through R9. So we put R8 on top. Done. So now we got the current here already. Can you follow? Am I going too fast? It's correct, right? Correct. Need to double check.
Feel the thing that shifted. Good.
So since this is the current, right, I just need to multiply by R11, and then I put a negative, right? This is VZ already. Like that. This is VZ. And then from VZ, how to get V out?
I need to send something before my.
Right, it's just VZ, right, multiply by R13 plus R11 parallel R12 over, right, in this case, we know the voltage, so it's R11 parallel R12, right, which is actually just equals to VZ 1 plus R13 divided by R11 parallel R12. Okay. Then we just plug in the whole thing. We get the V2 expression is negative V2, right? Then bracket R8, R11 divided by R7 plus R8 parallel R9, right? Then this is 1 plus R13 divided by R11 parallel R12. Okay, done. Okay, now we need to calculate for example, now we can calculate VIO, right? So here is 0 volt, right? So here is plus VIO, here is plus VIO. And then there's no current going through, so here is VIO. I can remove everything. So this is VIO, here is 0, 0 here. So there's nothing here. So you can ignore R6. Okay, so now we just need to find the current that is going here, right? So, actually going this way, lah. So VIO, right? We need to divide by, right? Divide by R10, right? Parallel with R9 plus R7 parallel R8. Like that. And actually, this is the same expression as before, lah. Right, same expression as before. So what we can do is, right, we just use this expression. We just use this expression, VIO.
What?
No.
Okay.
Okay. Done. VIO done already.
Wow. Yeah, I don't.
Like that, like that.
I don't want.
Yeah, should have.
Yeah.
Should be the same.
It's
the same as the V1 one.
Yeah.
So I don't have to redo again, redo the calculation. No. That's just the page number. That's the page number. Okay, so now we're done with the VIO already. Now we can do I plus. I plus is very similar also. So here is 0 volt, right? So there's nothing going through here. Right. So I plus we need to include R2 because there's current going through here and through here, like that. So the voltage here is what? I plus multiplied by the resistance, right? So it's just R2 parallel R3. Okay, maybe I like that. Plus R4, like that. Are you taking AE?
No, it's unlocked, right?
Yeah.
Good luck, guys. I'm not doing it.
You look like cancer.
Okay, so this here there's no current, so here the voltage is the same also. And then R6 you can cancel also because 0 and 0, so it doesn't matter. No current here, no need to care. Okay, then we just need to multiply this as with the bottom one. So plus I plus. And then I'll just copy the same thing. Like that. Okay. Oh, oops. Why? Oh, okay, can. Okay. So I pass done, right? Yeah. Should be quite fast. Once you find the voltage there and then the voltage divided the same, then okay already. I pass should be the same also. Yeah. Oh, I forgot the no it's plus is so. Let me see. Oh, it's minus. Wait, let me get back the expression. Oops. Let me undo. Okay. This one, I need to plug in this expression. Yeah, it's minus actually. Yeah. Minus. And then is R2, R3. Okay. So it's R2 parallel R3 plus R4. Okay. Okay, last one. Then we're done with this question. I minus. So here is 0 volt, right? When it's I minus, here is 0 volt. Okay, so now we know this voltage is right. I minus R5. Okay, R6 can cancel out also. Okay, so now this one we need to include R5 also because there's some current going down here. So we cannot just copy the expression. Okay, so what we need to do now is we basically need to do the same thing as just now. So what we do is I minus R5. Oh, I just do I minus first. On top is R5. Oh, sorry, maybe I'll just do I minus R5. Okay, this is the voltage. Okay, then it's 1 over, this is to find the current, okay? Find the current. Right, we have R10 and R5 in parallel. Okay, like that. Plus R9. Sorry, the whole thing parallel actually. This thing parallel. R9. R9 plus R7 parallel R8. Like that. This is the current. So the current going this direction. Can get it, right? These two in parallel because they are connected to ground, right? And then these two is parallel with this whole thing.
Current going towards this one. Left side.
Just ask, I'm pretty sure people got the same question.
You take I minus times alpha, you get a voltage at this number.
Because there's current going through here.
Yeah.
So why R5 and R10 are in parallel, right? Because there's current going through here, and these two are connected to ground, and you can see there's actually 3 things parallel. R5, R10, and the whole thing in parallel. Yeah. So I actually can do this also. I can just like that. Don't need to bracket. Yeah. This one is parallel with this one. Is parallel with this one.
This formula is R5 divided by R10. You get the voltage at the node first and then divide by the rest. He didn't add R5.
This is not correct though. It's not correct. It's not correct. It's not correct. It's not correct. He didn't consider current to R5.
Yeah, he added it. I think.
If you add behind, it's okay.
Yeah.
Is it? Oh, then plus he add, right? Yeah, he add. Then it's okay lah.
Okay now.
Yeah, correct lah.
Yeah.
But this is the way I do it lah. Yeah. Okay, then this one we need to multiply. We multiply by R11. We multiply by R11 become VZ. Become VZ already. Wait. Let me see. No, not multiply by R11. No, not that simple. We need to do 1 plus, yeah. So right, to get the Z, right, it's just 1 plus R11 over all this thing here, put inside here. Then here multiply by I minus R5. Oh yeah, so why is it 1 plus, right? Okay, I can write it out longer. So actually here, right, to find this one, right, is actually what? You agree is R11 plus the total resistance here, right? Because you can see this is as a voltage divider. So like the ground here, then this is R11, and this is Z, right? And then here is actually I minus R5, right? And this resistance is all of the resistance together, the R5, R10, 9, 8, and 7, which is actually just this one, like that. Okay, so it's basically just a voltage divider, right? So to find the voltage at Z, right, it's actually just, so I just take this as RA, for example. So to find VZ is equals to this voltage here, I minus R5, right, multiply by 1 plus R11 over R11 plus RA. Or if not, I do a longer form, right? It's actually just RA plus R11 over sorry, not yeah, correct. Over RA. Yeah, it's actually over RA. Okay, equals to I minus R5. This one, right, like that is 1 plus R11 over RA. Can see, right? Can see where I'm coming from. So RA I just plug in only. So I can find VZ. And then now to find V out, right? This is for I minus, right? It's just VZ multiply by, so it's basically the same thing. Is instead of RA is RB. And what is RB? Okay, RB is everything here at the bottom. This is another resistor. Okay, so I'll just write it out. 1 plus R13 over RB. And then multiply by, VZ. We multiply by VZ, so correct. Right, R13 comes from here. This R13. This is RB. Like that. So to write out the full thing, right? Okay, to write out the full thing. So now we got RA, we just need to calculate RB, right? So I actually am doing like multiple methods in one go, but sure. So RB is actually just R12 in parallel with, right, maybe I do a bracket, R11 plus, okay, R11 plus R5 parallel R10, actually I don't need a bracket here, parallel R10 parallel, okay, R9 plus R9 plus R7 parallel R8. Like that. But the answer is still correct, so it's the same.
This one is just this one. Then you take the whole current
Oh,
no this area.
yeah, looks the same. Looks the same.
Who wants this? Something else. I need to study for DSA.
Oh, today.
CSAI is today.
Very
Oh yeah. CSAI is to be
final quiz.
because your final quiz is what is paper, right?
Oh,
No,
bro,
no,
you don't have a final.
No, final quiz is on paper.
Huh? Is it?
No.
Final quiz is MCQ.
Oh, MCQ.
Short answer and MCQ, but
Short answer.
It's all MCQ. It's all MCQ. There's no
Short answer, I straight go and study.
but calculator, a bit.
You got no one. We need to calculate like Gini all this.
Yeah. But
Gini
most of the time it's
AI
those
only what?
sneaky syntax error.
Isn't it only AI?
No.
We only AI.
So they said AI.
Yeah, but don't know our one.
No, then it's AI. No, I don't remember.
They got syntax error check.
It's not R7, it's actually R11.
I don't know, it's so
Tedious meh? It's literally step by step. Everything is step by step. Very easy one. Then this is R12 parallel with R11 plus. Well, I need to do a bracket. Actually.
I first see the tutorial 5 or 6. Yeah, I didn't go lecture. Then I didn't know that you can use 7 equivalent after you solve the circuit for the diode. I just straight away use KBR and PCR. My paper is damn long. But it still gives you the answer.
Done.
Huh?
That's all.
Huh?
This is your answer. Okay. Hmm?
Yeah, this one I don't know how to say it. That's the comment here from there, right?
Yeah. Oh.
Oh, okay.
Same right. You look at this one, I minus 1.
Only the
No, this method will be different than
Where?
the final line. Your behind part, right? But this
Yeah, correct. Yeah.
one is
Correct. Here, this one is here, this one. R12, R11, then R10, R9, 8, 7, yeah, correct lor.
yeah, but he got a I minus time R5.
Because you're very difficult.
Oh, yeah.
Oh, I open up, right? Open up become the same one.
Oh.
Then this I minus R11. Oh yeah, R11 plus R. What is this?
I think that one
I think
is
it's
the
multiply. Yeah, correct. Correct. Yeah. Okay, next question.
Okay, next question I'm going to take my question.
Wait, how many questions are there here?
3.
Oh, so short ah. Wow.
Yeah, but
How long ah? 2 hours ah. Wow, so good eh. Oh wow, this is like interesting.
This one.
So you need to calculate.
It just briefly go through only.
Oh, interesting. Okay, so what do they want to know?
They want us to find REQB.
When they are forward bias, find the maximum I1, 2, 3, 4 when they are forward biased. Find the voltage VAB and okay.
We do the first positive level, then we do the other side. When it's like
No. They got plus and minus 10, so you get 20 volt total.
oh yeah. You do the first part.
So at first the current will go like that, right? Like that, correct? Then after that, when it's negative, you go like that, like that. So we need to do 2 calculations. But actually it's the exact same. We just do opposite only. So we just choose one. Okay, so let's do equivalent circuit. Let's do equivalent circuit. So what is the equivalent circuit? Oh, super easy.
Super easy.
Yeah.
Then we can give up.
Okay, so your RTH is 8 kilo ohms. You all know how to get 8 kilo ohms or not?
You 3
is it 8 kilo ohms?
3 parallel 3 plus 2.5 and 4. 1.5 plus 2.5 and 2 plus 2. Plus 2.
Need to plus 2, right?
Yeah.
Let's see. Oh, because I can bring out, then it's the same. So it's 10, yeah, 10 kilo ohms.
Wait, what? How you?
Okay, so I'll go through this for the sake of people who are watching this. Okay, for the sake. So these two combined together become 1.5 kilo ohm. And then 1.5 plus 2.5 equals to 4, right?
Oh.
Here is 4 and 4 become 2. 2 plus 2, which is here, equals to 4.
Yeah.
So here is actually 4 kilo ohm.
Yeah.
Here also 4 kilo ohm. And then here these two, right, we can either bring to this side or bring to this side, right? Because it's in series, it doesn't really matter, right? So actually 4 plus 4 plus 2 is 8. 4 plus 4 is 8, then 8 plus 2 is 10. No?
Mm.
Okay, very simple. Okay, like that, right? So once we're done with this already, once we got RTH 10 kilo ohm already, now we just need to find the voltage, the open circuit voltage. Actually, it's just 20 volts, so actually no need to worry. So VTH,
Need to bring my laptop.
20 volts.
Right here, I don't know what.
Right. So how we get VTH is 20 volt is it 20 volt? Got current going through, right, actually. Oh, VTH is not 20 volt, it's 10 volts only. It's 10 volts, it's 10 volts. Almost peak. Okay, so why is it 10 volt? Okay, so here, right, peak to peak is 20 volt, right? So here so this one is open circuit, right? Because when we're doing the TVH, right, we looking across here and here, right? So it's VTH. So to find the VTH here, we look at the volt. Here got no current, right? So here I can cancel use like short circuit like that. Here short circuit, here also short circuit because there's no current, right? So we can the voltage will be the same. So over here is actually 5 volt, right? Peak to peak lah. Oh sorry, 10 volt peak to peak, right? Which is actually just -5 to 5 volt, right? So over here is 5 volt, right? We're looking at the peak value, right? Because why? Because 3 volt, 3 ohm and 3 ohm, so you divide by 2. Here is also the same, 4 ohm and 4 ohm divide by 2, right? So here is -5 volts, right? So over here is -5, right? Because here is -10 volt, so -10 then divide by 2 mah, right? -10 is the peak So we are looking at the peak. Okay, so like that very simple, right? We get VTH already. So once we get the VTH already, now we can draw our equivalent circuit, right? So our equivalent circuit is actually just this. Plus minus 10 volt, right? This is 10 volt, the peak, right? We just pretend it's just DC lah, RTH is just 10 kilo ohm, and then we have a diode, like that, go like that. And this diode is actually 2 VD, go down is only 1 ID. Right. The reason why is it like that is because the current will go through here, 1 diode, 2 diode in series, and then these 2 diode in series, right, we have 2 ID, and then since these are in series, means there's only 1 diode there's no parallel diode, so it's just 1 ID. Okay? Can, right?
Yeah. Two VD and 1 ID. 10K ohm.
So remember, we need to refer to the bottom part for the ID and VD or the D solution. Okay, so we go to the diode.
Too fast. Next is what VD.
Oh, they give to you Oh yeah.
Yeah, I thought ID equal
So we take this, we copy, we go up.
Huh?
Okay, so I paste the solution, paste the crop a bit. Okay, like that. Okay, so this is a approximate circuit equation So right, NVT. So like we need to find these two, NVT and IS, very important, right? If you can find this, it means that we can kind of solve, right? We need to find this parameter basically, right? Okay. So once we got these two parameters, then we can solve. So what we need to do now?
Need to find VD given, right? What does VDS and VD1 mean?
Let me see how to show this.
No, there's something different. 它有两个 value 有两个 value。
超音很就是那个。
Right, we just lazy a bit lah,
Huh?
like that. I'll just copy from here. So it's don't waste time. Right, ln right ID1 divided by IS divided by ID2 divided by IS, right? So NDT equals to VD1 minus VD2 over ln ID1 divided by ID2, like that. Okay, and then in this case we got this NDT already lah. And then to find IS, we just IS equals to right ID divided by e to the power of VD divided by NVT. So these are the two important formula. Okay, then you all plug in first and then find NVT and IS. Like that.
I think you just take 0.254. That's a big deal. Yang sub eh?
直接上，
啊？
直接上完就给你了。
哦，VDS 的话就是1 and 2啊。
哦。
Okay, ready or not? Okay, so with that equation, what you're supposed to get? On top is 0.7858 minus 0.65 divided by ln ID is 3.2 milliamp divided by 400 micro, right? Okay, so your NVT you should get 0.0519 something. You got it?
0.6 Oh.
Is this the same as what you all got?
I see. E1, ID1. Oh, yeah. So 3.2 milli over.
Okay, should be the same. Okay, then now we can calculate IS, right? IS equals to? Okay, so ID on top. So we use the equation ID is, let's say we choose put 3.2, right, divided by e to the power of, right, VD we take is 0.758 divided by NVT, which is nano M, right? Okay, if you should by right you should get nano M, if it's not nano M means you're wrong already. Right, 68237056 nano M. Okay, so these are the two values that we got already. So from these two values, right, we can actually construct, right, our value, right, BG, the equation. So firstly, right, with our equivalent circuit, we need to determine the equation for ID. So ID equals to, right, just 10 volts minus 2 VD divided by 10 kilo ohms. Your VD is actually your equation of the diode formula NVT ln ID over IS. And then assume or let, right, VD equals to 0.7 volts. Okay, so we plug this 0.7 volts into this part here. I use in another color. So now we can get ID equals to, okay, so 10 minus 2 times 0.7 volt divided by 10 kilo ohms is, right, 860 microamps. Okay, so once we got this 860 microamp, right, we can get VD already. Equals to NVT, right, ln, right, divided by IS. Okay, ID is 840, right? So now we should get VD equals to 0.689756119. Are you calculating or not? Are you copying my answer?
You're too fast already.
How is this fast? Just type calculator only.
I can also very slow. Need so much decimal or 4 decimal can.
No, I just write long so that if it's the same answer means you all will get the same, right?
Yeah, okay.
Yeah, doesn't matter if you choose whichever for the 1 or 2.
Usually because they're in the same line.
It doesn't matter. It's just 2 points. You just reverse the 2 points, you still get the same gradient. Yeah.
Oh.
NVT ln divided by IS, then answer. So your VD equals to 0.689879702 volts. One last time. This one should be the easiest question, I think. Very minus 2 times this one divided by 10K. Okay.
Oh, yeah, copy the 3 times 8. 3 times no. Yeah, that's constant.
Then VD equals to, okay, VD equals to the same thing again. So it's NVT ln divided by answer divided by this one. Okay, so we got this value. So now we got these two values, yeah?
So this is our VD.
So we got VD already and ID. Okay, so now what the question asks? Okay, so find the maximum ID and VD for the diodes, right? Actually, we got it already. This is the maximum already. Okay, when you're in forward bias. I got micro amp lah. Actually, milliamp is just 0.8 lah. So whichever floats your boat. Okay. So hence find the voltage VAB and the current for RAB for part VI. Very simple. Just the current multiplied by the resistance side of your voltage. Current is actually just your diode current. That's it lah. Simple. So VRAB, right, equals to just ID times 3K. Just that only. That's all. And times 3,000.
What is the RAB?
Done. So full marks.
ID times 3K.
Yeah.
The RAB. Oh.
You can write it a little bit more like specific. You can write a piecewise function to determine the square wave, whatever. Also can if you're happy. Right. Is it 2K or 3K? It's 2K lah, not 3K. Careless mistake. I thought it was 2K. So it's divided by 3 times 2. So it should be 1.7.
1.7. 1724. Does it have to be that much or
Whatever lah. Whichever SF you like. I like to write the full SF.
oh, they don't specify also. Oh, 3 decimal point.
Okay.
What the heck?
Okay, done. So this is how many marks? 6 plus 10 plus 4, 20 marks.
And the first one got 40 marks.
Oh,
First question.
First question.
40.
20 plus 20 mah. Then the bottom one should be 30 plus 30 lah.
Yeah.
Okay, can. Okay, ready for question 2 or not?
No.
Ah?
Yeah, I thought this one is discussed yesterday. Right.
Hey, it's
The same one.
Yesterday's question.
wait a minute. What the heck? Everything's the same. now got VCC and VEE lah. Oh, this one is PNP. That time was NTN.
Oh.
Yours still want to do or not?
So
Yes.
I don't understand BDC and all that.
For completion's sake.
Everything also do that.
Question 2 and 3 I don't know.
Yesterday you play what? You see what high frequency, low frequency.
Yeah. Oh, okay.
That one is for the step response. Right?
Yeah, I don't know. Yesterday he used one.
Oh. The C CR omega thing. That one is question 3.
Yeah,
Normally question 3. Yeah, question 3.
Okay, ready or not? Ready or not? VEE is what? VEE is 10 volt ah.
V 10 volt, 10 volt.
Here is negative. Is it 10?
Yeah, 10. 10
Okay.
and minus 10.
Okay, so everything else okay lah. Oh, ready or not?
Huh?
Ready or not? You ready to do?
How to do this question?
Okay, fine. Calculate the DC operating point. So DC operating point, what do you do with the capacitor?
Remove.
Open circuit ah.
Yes.
Hey, don't say short circuit ah. Open circuit ah. So here ignore. Here is open circuit. Ignore here.
So which
Right, you ignore here, right?
we get RE.
Okay, to make everything looks nice, I will do a nice one. This is open circuit. This is open circuit. Open circuit. Okay, so what do we have here? Okay, we just need to do a resistor. Okay, good. Okay, we for DC operating point, once we clear the capacitor, open all capacitor, then what's the next step?
Draw the equivalence.
Yes, very good. Draw the Taiwanese equivalent circuit. So Taiwanese equivalent circuit, right? We just need to draw a like that, right? To ground here, and then resistor, and then we have the PNP, and then we can have this one we can just call RC lah, huh?
Yeah, RC and RE.
Yes, very good. RE. Okay, then here is VEE. Here is VCC. Okay, negative 10 volts. Whatever you want to call it lah, huh?
Oh, so we can put anything we want there.
Yeah. So here the current is called IC. Is it correct? IE, sorry. Here the current is IC. Here is the emitter. Here is the collector. Here is the base. Here is the base current, IB. Okay, so it's RTH here, and this is VTH. Okay, so actually VTH is actually 0 lah.
Why?
Is it 0?
No.
R1 and R2 is different, right?
R2.
Okay.
Should be.
Immediately it's like it's wrong.
R1, R2 is the same, so you just
Oh.
VTH is 10 volt only.
Huh? VTH is 0.
Why? Because we got 10
Okay lah, but if you take according to the negative, okay, if you take according to the negative, right, VCC, right, then yes, this is 10 volts lah.
Yeah.
Yeah, you can take according to VCC lah. Okay, sure lah. Then this is 10 volt lor.
Huh?
Can lah. Whichever you want lah, whichever you want.
Wait, is that correct?
Zero, we are respecting the ground.
Yeah, with 0 is respect to ground. Okay, but I just do with respect to VCC then you have 10 volt.
Respect with VCC, VCC is 0, right? Then
It depends on whether you do just not respect to ground, so it's 0. Whichever floats your boat lah. As long as your boat floats lah.
Oh, wait.
Okay, so RTH is what? It's just 50k ma.
Yeah, because the ground is not open, there's no ground there. Yeah, but because this one open circuit, the ground there gone already.
No, correct. It's correct. Here, we are just finding the equivalent circuit across the base and this one. For example,
Yeah.
if it's across here and here, then it'll be 10 volts lah.
Ah.
Yeah.
Yeah.
sure, man.
across the base and the VCC. Right, we are just, for example, we take a voltmeter here and a voltmeter here. Here the plus, here the minus. Right, when we take out, right, here will be 10 volts, correct? Because here and here, these two are the same resistance. So 10 volt and 10 volt is 20 in total, right? In between is 10 volts. So what we measure is 10 volts. If it to ground, right, is also the ground is 10 volts from negative 10 ma. Yeah, so if you put ground, it's the same thing as putting 10 volts according to VCC lah.
So it's 10 go.
Yeah lah, you want to put 10 volts also can lah.
But then
It can be 10, it can be 0, but your ground must your negative side of the VTH, right, must be set correctly. So if it's 0 volt, right, the negative side is ground. If it's 10 volts, right, the negative side is VCC. Yeah. But in the end, the voltage is 0 lah, still, right?
why is it?
Then the RTH is from where?
RTH is the same thing. So just now we measure from here and here, right? It's just R1 and R2 in parallel only. R1 and R2 in parallel. We measure from here and here, right? What do we see? We actually and everything is short to ground. Everything is all shorted, all 0. So here and here in parallel only. Everything else is the same. So now we got this already, right? So remember, you need to do the KV outlook.
Allow my laptop so laggy. I need to swap the drive. Yeah.
After exam 再做这些东西。
Yeah. The Samsung drive damn shit. The default one they come with the laptop.
Okay, so now our KV outlook is from here, right? Like that, right? Down here. Correct or not? Because VBE is equal to 0.7, right? We assume, right?
Always assume.
Yeah. We assume is in a forward active mode. So it's 10 volts minus IERE, okay, minus VBE, right? Then what? Plus IB,
Plus IBRP.
RTH, yeah. Right, equal to 0.
IB plus. Oh, sorry, I need.
Can get IERE is here, right? VBE. VBE is minus VBE plus VBE.
Plus VB.
Yeah, plus VBE, right? Yeah.
Plus. Minus VB. It's just very VB.
It's plus VBE, not minus. Yeah. So plus VB is correct, or it's minus VEB lah. Yeah, whichever you float your boat.
They teach VB, use VB.
Okay. Can. Right. Is it VEB or VBE is 0.7? Did they say that? VBE, right? Oh wait. Yeah, correct.
VB. They give VB for 7. The question is VB.
Oh, on top VEB is it?
Yeah.
VEB is 0.7.
Yeah.
Oh, okay. Then I just write minus VEB. Okay. Yeah. Okay, then everything else should be correct. Because the IB is the I current is going in this way. Right, so here's the minus, here's the plus. So far the current going down here is plus, minus, then E is plus, B is minus. So here is minus, here is plus, then it must be opposite. VDH. Here is 0 volt. Here is 0 volts. Remember 10 plus negative 10 is 0 So here is 0 volt, so it's equal to 0 The voltage is 0 already. So I don't need to go and put VTH1 nonsense. Because 10 plus negative 10 is just 0.
Oh.
Yeah, can. So 10 minus beta plus 1 IB RE minus VEB plus IB RTH equal to 0. Then we just need to solve for IB.
Actually, you put the wrong sign. The whole question just goes wasted.
So your beta is 60. Beta is 60.
Wait.
Okay.
If isn't IB going supposed to go to ground?
The other direction is it?
Yeah. 0 volt, man. 0 volt that side of low potential.
IB going the left side. Ah.
Yeah.
Okay lor.
Alright.
Can. Then we do like that.
I confused, yeah.
Cause this is a PNT, so it's the opposite direction.
Yeah.
Can. Let me see. Actually,
Wait, I open lecture note.
it should your current will be negative lor. Yeah. Your current will be negative. Actually, it should be like that. Actually, should be like that. Correct.
Yeah.
Should be like that, right?
Eh?
Why?
Wrong. Like that.
Because PNP IB should always go to the ground side.
Okay, actually like that makes sense because it's supposed to be from 10 volts down, right?
Yeah.
Okay, then lor.
Let me pull out.
More negative. Yeah, correct. I mean, in actuality, it's like that. In actuality, it's like that. Yeah. Because it's positive go down. So in actuality, it's like that. So just now I draw the IB directions wrong. So the arrow is supposed to be all negative at the bottom. Supposed to be all negative. Okay. Yeah. Good to spot the mistake. Very good. So you just need to solve for IB. Solve for IB.
Only got 2 IB. Calculate IB. Beta 200.
So what answer do you get?
I only type 3 lengths. IB sheet has only 2 separate IBs. Open or not? Yes. Why they come out monster with each other?
Yeah, sorry.
Oh, monster is yeah. Last time count BJT.
It's the first time.
Last time and previous time count.
Last time was the first 2102 paper, right?
Yeah, that's
This one is the-
maybe that's better.
Nah? Monster we don't have up now. But then the rest I don't know how to calculate also.
Is it one minute?
So it's 1.002581, right? Micro M. You got that?
1.005. Never mind lah.
As in, it's just one. I'll just take 1 milliamp. Sorry, 1 micro M.
Oh, micro M, sorry.
1 micro M.
Right now, your calculator can help you solve it.
Oh.
Like that.
Oh, you put X
I don't know how to use.
You type everything, then IB you put X there.
Then mine
IB you put X.
is 60. Beta is how much?
No,
You put X and you put the
Beta is
but
Run into like
a very long calculation time is a bit
more
more
complicated than linear.
Eh?
You know what the money go like?
What?
Is equal is here.
60 plus 1 X ma.
Uh,
Okay, so for those listening, right, if you have this calculator, the 991EX, right, the class fees are, go and type 10 minus 60 plus 1, then you put the X times, right, your value, right, 131.6 kilo, right, plus 20 kilo, right, minus 0.7. Actually, if we get one micro means our answer is correct. Minus X times 50K. Right, and then after that go and click shift, and then we click solve. And we click CALC right, on your calculator, which is actually solve. Right, solve equal, right? Then after that you press, once you get this way, shift solve. Then you X equals to blah blah blah, right? You put 0, right? Because the right side is 0. Then you press equal.
X equals 0.
Then after that, right, your answer X you get 1.000, 1.00, 2581, right, micro M. Wait, what happened to your calculator? You need to be multiply.
You need to be normal mode.
Normal.
Then the
No, I medium mode.
then calculate.
Yeah, but then I don't know why your number so big. You never multiply correctly or what? This one is times, is it? Times or plus?
You are entering multiple.
Oh.
Blah,
Blah, blah. Oh yeah. Times.
Let's calculate and you set x equals to 5 and y equals to 4. Then you calculate this
Plus
and
20K.
you change the next variable. So you use it for
What the value different?
How much you got?
To repeatedly calculate the same function.
Oh, that's right. You know what? I will still do the wrong way. This one is 7.3 and what? Thank you.
You just click shift solve.
Oh wait, I should get 0. Yeah, you get 1.16. I think because I use the K and
Okay.
can use K also.
Where is key?
It's not there. You must click shift. Sorry. Just click option. Then click 3 engineering symbols all here.
Oh.
Yeah, faster.
Okay,
So save time.
Yes.
Okay, so now we have one micro M.
Wait, how you click again? Shift solve. Oh, enter. Oh.
Wait, you got engineering symbol?
Option, press 3.
Oh, it's here.
Then engineering symbol.
I always thought
Save time. Go from 10 to the power 3, 10 to the power 6, all this nonsense. Just option symbol can already. Option 3. Okay, very simple one.
Holy shit.
Yeah, save time lah. Why you all want to make yourself suffer so much? You know your constants are also here, right? Shift, constant. Then you have like speed of light lah, length constant lah. Yeah, right. Your electron charge.
only I don't even know.
Right, 9.11 times 10 power negative.
Constant is here, but you need to know. Yeah.
Okay lah. Your calculator can work for you, okay? Don't work for the calculator. Okay, so now we got IC already, right? So we need to calculate VEC, correct?
I B is 1 micro and IC.
Okay, VEC equals to 10 minus. Okay, so maybe I'll just do like that first. VE minus VC, correct?
Do we need to find ID?
No, we need to find IC and VEC. Remember, these are the two important points, man. IC and VEC. Okay,
It's what V minus what the heck?
Okay, this is VEE minus the IERE, right? Okay, now you get VE already, correct? And then C is what?
SCRC.
Okay, this one is ICRC plus BCC, correct or not?
Oh, you just write it then. Okay.
You not agree or not?
Agreeable.
Must agree on. Okay, what's the answer? This one shouldn't need much help to calculate, right?
I need beta.
Beta is 60.
Yeah. 10.
So VE is 10.
10 minus 61.
So it's 61 times 1 micro, right? RE is 131.6 kilo plus 20 kilo, right?
131.6.
Minus IC is 60 micro.
Times 20.
Right, RC is what?
Minus
150K plus 10.8K. Right. Plus VCC. VCC is negative 10.
minus
Okay.
I see 60 micro.
Okay, got answer? Eh?
C is 150 plus 150K plus 10.
Yeah,
Huh?
come on.
You're taking along.
She can choose to take.
No, I'm done with it.
The thing
I want to keep for that's the thing. Scientists keep for.
It is just part A only, 10 mark only.
The VCC, do I need to put a minus 10?
Yes.
Yeah.
Is this the paper last sem?
Yes.
Oh my god, this looks like the paper.
What did I get negative value? It's
I
negative.
Yeah, because
How can it be 16 kilovolts, negative 16 kilovolts? Confirm somewhere wrong already. It should be around 1 volt one.
1.6 volt.
0.2 to 1 volt around there.
1 volt.
Or 1.2 around there.
Oh.
I am not relevant that culture.
Oh my god, Emma.
I can't. I wait until I grow old.
Still got 1 hour. 没有的有你。1.1.
Yeah, 1.14, 1044.
Okay.
Okay, I grow old already. Graduate already. Okay, so now we finished the part A already, right? DC operating point, the Q point we already got. So now we need to calculate the voltage gain. So in order to do all this is actually the small signal model. So for small signal model, capacitor must be what? Short circuit.
Oh, yeah.
You scared you say the wrong answer, is it? Okay, so what about the independent sources? Independent sources, what do you do with them? Yeah, very good. So we ground them. Okay, so remember our this BJT diagram.
Nope, give up.
This is base, this is emitter, this is collector, right? We need to draw the equivalent circuit, correct or not? So this is equivalent to what? Remember there is this R pi, okay, and then we have, so this is D, right? Okay, and then we have the, this thing is pointing from C to E, so I draw this first.
Yay.
Okay, like that. This is E, this is C.
Oh, sorry, this is common base.
I draw like that. And then like that.
I got 2 C.
Oh, I wrote wrong. Like that. Not. Okay, then how do we combine them together? The R pi is connected across to the E, right?
Yeah.
So like that. R pi, this is B, right? This is E. Can it should be like that. This is from my memory, so should be correct. Okay, continuing. Huh? Yeah. Why you don't believe me?
No, because this like different drawing. See, yeah, they are one like this.
Same.
Yes.
Across the BB on this.
Yeah, so we control like
Okay, let's start with the input side. Okay, I draw like that first. Plus minus, this is VI. Okay, there is this RI, correct? Ground this here. Right, through the capacitor, and then there is something RE1 to ground, correct now? Can see? Like that, right? What I see here, I can look at the left first. This is to ground, right? We short all the independent sources, right? So here is all to ground. So what we see here is this one to ground. And then what we see on the other side is the emitter side, right? Because it's short through here, so this one can ignore.
so we just go straight go to up.
So we go to E immediately, right? So here we go to the emitter.
Yes.
Okay, so in this case, do we actually have R1 and R2? Do we have it?
No.
Okay, so here is short, right? Here is ground, right? Here is ground. Here is ground. So do we have R2 and R1? No, so we don't have these two. And then what we realize, base is actually connected to ground, correct?
Yes.
So base is connected to ground. So what we can do is, right, this is emitter, right? So I draw like that. The arrow point towards, very lousy drawing. Okay, like that. Arrow, GMBBE. This is E. And then we have one goes to ground, which is your R pi actually. Sorry. This is base. So the ground is actually connected to the base. Can see, right?
Yes.
Okay. Then like that, what we have is, this is the collector side. Then we can draw the R naught across. Okay. At the collector side, what do we see? Right.
Collector size.
We see from here, this is the collector, right?
Yes.
We see RC2, and then we see these two in parallel, right? Okay, so we see RC2 first in series. Okay.
And parallel RC1 and
Okay, then after that, what we have is here to the ground, RC1. And then here is the output, right? RL, right? Yeah, correct. Okay. So what we see here is actually R out. Okay, what we see here is R in.
in is behind I.
I just write like that for me. Maybe I use another color.
How does it include RL?
No, RL don't include RL.
Anything big.
Because you remove the RL.
Oh.
Okay. Okay, now what do we do next? Now calculate voltage gain. So voltage gain, do we need to ignore R naught or not? Can we ignore R naught? Do we need to ignore R naught? Can we ignore R naught?
AVT.
Okay, I thought I said this so many times already. Even in the review,
No,
say I remember R naught.
R naught. I can.
Everything don't need R naught except for R out.
Oh.
Okay, I remember only R out need R naught. Okay. If you want to calculate with R naught, also correct lah. But yeah. I actually like to do that, but
We need to calculate AVD.
yes. So in this case, right, what do we do? Okay, so let me see.
I'm doing my cube. I put water. PBOVC. PBOVC.
Okay, so in this case, we can have an expression for V out, right now. What's the expression for V out? Right, so we know there's a current here, right? So the current is drawing everything up, correct?
Yes.
Okay, so this current, we need to find the current that's going through this RL, right? Because the RL is for this V out, right? So what's the current for this? It's actually what we need to split, right? So we need to do RC1 divided by RC1 plus RL, correct? So this is the current through here, multiplied by GMBB. Right, and then we multiply by RL. So I can put RL on top. Right, and then RC1. So V out is this expression, done.
Oh, it's just literally parallel.
Not confusing, right? Actually, I'm missing one more thing. It's a minus sign. Because the GMBB is going the left side, so it's minus sign. So this should be the correct answer. Should be correct expression already. Okay?
Then B.
Okay, so how do we do the V inside?
RI divided with RE1. Voltage divide, yeah.
Okay, so current going through here,
Okay.
right, is the sum of the current going down, going here, right?
Yes.
So it's actually what?
If I doing parallel with RE1 up.
In this case, we can just do VE first lah. VE. Yeah, we can do VE lah. Right, just to be a bit shorter. But let me see. Maybe there's a better way. Yeah, cannot. Okay, so VE. Let me see. I just VI lah. VI minus VE, right? Divided by RI equals to the current going in equals to VE divided by RE1 plus VE divided by R pi, right? And then GMVB is going in, right? So it's minus GMVB. Okay, got this expression here?
Yes.
Where?
Where?
Where? It's just the current through here. So actually, don't need to care about RC2 because we only need to, for example, right? If you know the current going down here, right? It's just this current times RL.
The current through RC2 is split between RC1 and RL.
Like that, like that.
So they are, if you add those two, you still get the same current as RC.
Yeah. So actually, there's no need for there's no need to include RC2. Okay, so VBE equals to what? In expression of VBE, is negative VBE current?
Okay.
Correct, right? B is ground. Correct. So VI minus plus VBE over RI equals to, right, negative VBE over RE1 minus V. I'm just writing this for better understanding only, but actually can shortcut one. Right, this is same also. You see, right? Okay, maybe I need to separate this a bit like that. Okay. Okay, so VI over RI equals to, right,
Negative I.
I'll just put VBE here lah. Right, 1 over RI plus 1 over RE1 plus 1 over R pi plus GM. So VI over VBE, sorry, suppose also can about whatever. I just do VBE over VI. Okay, hopefully it doesn't seem like two big skipping steps. Okay, can. And then since we do this, what we can do is, right, we can express, right, the top part over here. So I just cut off here first. Here is V out over VBE equals to, right, negative GM RL RC1 over RC1 plus RL, like that. And then to get AV equals to AVT times, actually this is AVT lah, right? Right, times VBE over VI. Okay, which is equals to this one times this one. Then your answer, done.
Wait, VD over then VB. How you get until V out over VB?
Where? This one?
Yeah, that expression.
No, this one just divide over only, nothing else.
Okay.
As simple as that.
Then the VB over VI is for.
This one?
Ah.
This is two separate expressions. This one and this one is two separate expressions.
Oh.
This one is with VI and VBE, all with the VBE, like that. Actually, this question is quite simple. Very good already. No need to think so hard. This one like that 3 mark. Very easy.
Wait, I'm trying to understand.
Okay, then you just need to plug in the value only. So we can go and calculate the GM, R pi, and R naught, right? We haven't calculated yet, actually. We haven't calculated yet just now.
GM alpha.
Here.
GM they complete. We need to calculate GM. They give VA though.
Yes. We need that one.
VA is what?
Early voltage.
Early voltage.
Yeah. The early voltage.
Early voltage.
You know your IV characteristics, and then it has to cut off at the back. That's the reverse side, yeah. Okay, so what's the value for GM? All this.
VA plus VC. Oh, I see.
You calculate all this, right? GM is IC, right? IC is micro divided by 60 microamp, right? Divided by VT, right? So what did they tell me for VT? Did I copy the wrong one? No, correct.
GM is IC and then IC just now.
Wait.
Wait, that means GM is just 60 micro.
What is VT again?
VT?
25 micro what? What did I use again last time?
What is that?
Yeah. It's 40 IC lah.
Oh, okay, I see.
Just 60 micro times 40. So it's just 2.4 milliamps. Okay, so beta is 60 over GM, right? GM is just now we calculated, right? 2.4 milliamps. So in this case, R pi we get 25 kilo ohm. Right, R naught is just the early voltage divided by IC, right? So what is VA? Early voltage 80 volts, right? So 80 divided by 60 micro, right? We get
GM. Oh, I see.
right 1.33 right mega ohm, right?
So high.
Which makes sense. It needs to be large.
Is that why they say just in more?
Yes. Actually 100K is really large, but this one is mega some more. 10 times more. This is VI, just not the thing cancel out. Okay. So now we just need to apply lah. We need to apply all the values. Okay, so can do it together.
Slow.
Okay.
So just calculate ABT and ABT first.
RC1 is 150K divided by RC1 is 150K plus RL is 200K times. I need to draw this inverse. That is
RL is
RI is 100 ohms, divided by 100 ohms, plus GM is 1 over RI 1 over RE1 R pi.
is EE2101.
0.025.
Huh? What is that?
Yeah, I copy again. GM.
ABT. My ABT is 105.
It's 200K times RC1. RC1 is 150K. Divided by RC1 is 150K. Right. Plus RL is 200K. Multiplied by the divided by RI first, so it's 100. Right. Then GM plus GM. So 1 over RI is 100 plus 1 over RE1 is 131.6 kilo plus 1 over R pi. Yeah, I get the same answer.
Negative VBE is sorry, 1 over R2. 1 over RI. Sorry, down for negative.
So can you get the answer? Is it 0.025? You get it?
Not so fast.
I thought you just type in the calculator.
Over R2, RI is
Yeah, you got some time.
1 over R pi is plus RE1. RE1 is what is RE1? Yeah.
Different. Don't tell me it's different. If it's different, I'll be like, oh no.
It's 35.6 milli.
Oh yeah, correct. We got the same answer. So is it correct? Correct. We get the same answer means should be correct, right?
GM got S. AV is what? AV is just. AV got nothing.
Only 3 questions and then 2 hours. I think you can do like almost 3 times the paper. 3 times over.
It's only. Knowing Dr. JJ changed the thing for exchange.
Okay, so can we continue or?
Dr. JJ recently just say that you cannot go exchange for analog.
I think that should be a good thing, right?
No.
It's easier already.
Taiwan go Germany to take analog.
Oh yeah. They cannot already.
Their analog got no finals one.
Oh, what the? Okay. No, but I think it's good to have this fundamental input resistance and output resistance. So ready or not? Ready for input resistance?
Yeah, let's go.
Okay. So RE need to include R not?
No need.
Okay, very good. It's just need to get familiar with the terminology.
Optional.
Okay, so how do we calculate the R in?
R in is
I also need to think.
GM.
Oh, remember we need to do a test because no way that we can actually get the what, right?
We need to pump in some
Mm,
1 volt.
Okay.
Is it how we test level?
Well, actually it's super easy.
Is it how we test level?
Yeah, exactly. You're right. Okay, so let me maybe draw it out so that it's easier to see where I'm coming from. Yes, very good. Let me see where to put empty space. I need some grass field to put. Okay, let's find an empty field. Okay. Okay, then I'll draw a line across. This is R in prime. Okay. Oh, actually it's like perfect, right? Like freaking nice. So I inject a source. Okay, I'll explain why I put a voltage source, right? I put a voltage source. So this is called V test, huh? Okay, can see, right? Makes sense, right? RTH equals to R in prime equals to V test divided by I test. What we are looking for is what? I test, right?
Okay.
You can ignore this one. Okay.
So in drawing we can just don't draw R, right?
Yeah. I like to draw because it gives you better understanding, but it is preference. Okay, so now we got this, right? What do we do now?
We calculate.
Mm-hmm.
I don't get how to do the GMV part.
Oh, it's super easy. I'll show you. V test. I is what? The current is what?
GMV or IE. Yeah.
V test divided by R pi plus GMVBE. That's all.
Oh,
Done.
eh?
Yeah, that's all. And VBE, right, is actually equals to what? Equals to negative VE, right? Which is actually negative V test. Can see?
Okay.
Yeah. That's why I say this one is easy. Common base.
R in prime equals
Very easy.
V test over I test equal to V test over V test.
Okay, I lazy go and write. I copy and paste. Like that.
Wait, the RC1, RC2, all those don't care.
Don't care because you know the current one. This is the current is false one. This is the current, confirm is this current.
Oh.
So like that, the answer is actually just equals to 1 over, right? We cancel out all the V test ma, right? So like cancel like that. Right, we divide by that one. 1 over R pi minus GM. Okay, this is R in R out. Sorry, R in, right, just equals to, right, just now we look on top. What is the value? RE1, right, parallel, right? So it's just RE1 parallel with R in, no? Very easy. Okay, so now we just need to find what is RE. RE is what? 1.131.6 kilo ohm, right? Okay, so it's 131.6 kilo ohms, right? Plus okay, 1 over R pi minus GM.
For most of it, it's all the same thing also, right?
Yeah, actually, I need to do this, right?
Yeah.
Let me check. I think that one is negative value actually. 1 over R pi is this one minus GM. Yeah, it's negative value. Yeah, so I need to absolute it. Then this answer parallel with 131.6 kilo. Yeah, anyone get 442? 422, I mean. You got the same also? If you got the same, I don't calculate again. Okay, close enough.
Just in case. EE1 is how much?
Absolute sum parallel with RE1 is 131.6 kilo. Yeah, 422.
Then I take a 422. 422.37. 0.37. Then
Okay, is this better? I brought less of it.
This one. So thin.
You can connect with my computer.
I press control. Control got nothing, right?
Hopefully. Later like crash. Okay, done already? Okay. Is it too fast? Very fast. We haven't go to question 3 yet. Exam finishing already.
Then we don't do question 3.
Oh! Hey, then 30 marks gone eh. 30 marks. Cannot, must get full mark. Full mark. Okay, output resistance are out. Output resistance are out. Okay, we look at this again. Okay, so now we calculate what is R prime out. Okay, so what do we need to do now?
Find R prime. R prime is what? C2? No. GMVBE plus 1 times R naught.
So now for calculating R out, do we need to include R naught?
Yeah.
Doesn't sound very confident. So need to include.
Maybe.
Huh?
Yes.
Now become maybe already.
Yes.
So yes, yeah. So cannot ignore. Okay, life not too pretty.
It's what C2. VVI. I thought I need to change the VI to the other side.
So in this case, this one is short, right?
Yes.
Well, actually, I can just draw something like that, like short.
Just erase that. I also need to copy. Copy also.
No need lah.
Of my one. Copy paste.
Okay, so now how to calculate R out? We don't have any clue.
This is the part I don't understand.
Oh, okay, I know already. Okay. Very easy. Everything very easy, right?
I know is what
Okay, so now what we have is we do a test. Remember, we just need to do a test. Okay. I test. Okay. So RTH equals to right R prime out prime out. Okay, R prime out. This is equals to V test over I test. Makes sense, right? So how to continue from here?
GMVB plus I test.
So we know what is I test, right? We what value we set, right? How do we express everything on top? So V test, right? How do we express everything on top of V test, right? As I test. Yes. So actually is equals to, right, voltage across RC2 plus voltage across R0 plus voltage at E. Correct or not? This is everything, right? E. So I'm building up, right? So I build up from ground to E, and then E across to C, and then C to, right, V test. Right, this is VRC2. This is VR0. This over here up like that is VE. Okay, I hope this should be simple enough to see.
No. Can explain again the
Okay, so you can see this is VE, right? Okay, so VE is according to base, according to ground, according to ground. Okay, so VE, so to what's the difference between E and C, right? The voltage across here. The voltage across here is the same as the voltage across R0, correct? Right. So you from here you add add VR0, right? It's actually C, which is VC. Once you get VC already, right, you add the voltage across this resistor, you get V test, correct?
Yes.
Okay, then that's it. Right, this is VC. So how can I express each and every one of these voltages in respect to I test? Actually, this is the Dr. JJ method, not my method. Okay, very simple, right? This one should be simple, right? VRC2, I think you all should know how to get, right? How to get
VRC2.
the voltage for RC2.
I test plus GMVB.
Yeah. Okay, can. So it's just I test, right? Multiply by RC2, correct not? There's no GMVB, just this is the current, right? Going down here. Right. So I just need to this one voltage equals to R times I, resistance times current, so I just the current through this one. Okay, so V R0. What about the VR0? What's the voltage for R0? How to get? To find the voltage, I need to find the current, right? Current, how to find the current?
Voltage or resistance.
Yeah, the total current minus the GMVBE. Then I get the remaining one, correct or not? So it's actually just I test minus GMVBE. Right, then the remaining is R0. VE is what?
VE is the front two parts together.
How to calculate VE?
I test parallel with RI and R5.
Right, multiply, no.
Multiply
RI parallel with
RE1 and R5.
Very good. Can? Good question. Yeah, so how? So VBE equals what?
Negative VE.
Negative VE.
Yeah.
So VE is what? Correct. So actually, right, maybe I'll just write here first. So RC2 plus, right, in this case is I test plus GMVE, right? Plus VE. Can you see? Right. Equals to VRC2 plus I test plus VE bracket 1 plus GM. Can? So with this, I can actually get this. Okay. So I can actually cancel I test everything. Oh, I'll just write I test for the sake of everyone. Sanity. Right. So plus let me see. I test R not. Actually here got R not. Right, then GM R not also. I missed the R not here. Here got GM R not. R not, and this is R not plus, yeah. So it's I test
That's a big mistake.
R not, okay, plus I test RI parallel RE1 1 parallel R pi, okay, and then right, this is actually what? R naught plus GM, right? Divided by I test. Okay, then your answer should be RC2 plus R naught plus RI parallel RE1 parallel R pi R naught plus GM. That's it, yeah. These are R prime out.
What? This part is for what?
Where?
This the
This one, right? This one over here is just to explain how do I get from here to here. Because I got just now you asked a very good question. What do I do with VBE, right? So VBE is actually equals to negative VE, right? And negative VE, right? I plug inside the GM VBE, so I put it here. So everything comes back to here, right? So this one is this one. This VRO is actually this one. VE is just VE. Can you see? VRO I open up already. Can you see? I test RO plus, because negative VBE, so it's GM RO VE, like that. So I can combine this VE together, become is actually 1 plus GM. I keep making this mistake. Okay, okay, can see, right? Then VE is actually just this ma. Sorry, VE is actually just this one. Yeah. Okay, here I write nicer a bit lah, right? Yeah. Okay, there we go. Like this. Emma.
I'm still trying to understand your wish.
Yeah, let me get the value at the top. RC2 is 10.8 kilo plus R naught, right? Plus the whole thing in parallel, then 1 plus GM R naught. Okay, then I need to add those in parallel. RI is 100. RE1 is 21.6 kilo inverse plus R pi. Okay, so now we got answer. So let me explain anything. Everything again.
I don't get how why the 1 plus GM are not applicable?
Here. I just open up the VR not only. I just open up. This so from here to here, right? You also can see also lah. But to make your life easier, right? I don't open up the VRC and VE. So right, VRC2 and VE I just leave it like that. VR not I open because right in the end there's a GM there. Or sorry, VBE there. VBE there. So if there's a VBE there, I want to open up. So become like that. Right? I put negative become VE lah like that. Right? Because VR not is actually just I test minus GM VBE. And actually VBE right is actually negative VE. And this VE is expressed by I test times this one, this whole thing. So right, actually this one bring inside here. And then become positive. Like that. Right. But then because I want to jump step a little bit, so I will write this twice, right? So I just write this, right, to make it easier to understand.
This one is VE.
Right, VE or equals to negative VBE. Right, then I put this inside here. Okay.
This one often die.
Why die? This one should be very simple, right?
You have to think of that kind of thing.
No, at the time I didn't think of this also. But once you do it a few times, then should be okay. But make sure just practice or practice faster paper. Yeah, just get used to the method. Okay, so this is the method. Okay, let me explain one quick time again. Okay, so now we have this circuit. Right, we have this circuit. Right, we need to find right R out prime. Let me erase this. Actually, this is not the full answer yet. We need to this R prime only. Okay, so we want to find R out prime, right? So what we do is we need to inject a source, right? A voltage or current source, because we have a dependent source. And then what we see is this is just one resistor, right? This is another component, and lastly this is one component on its own. To determine the RTH, we inject a current source, right? Because in this case, the calculation can be easier with current source, and from the reasoning, you can actually see why. So we have I test going up, we have a voltage drop over here, a second voltage drop over here between E and C, and lastly between E and ground. So we can separate this into three separate parts. You can see, right? So these three separate parts contribute to this, right? VRC2, which is here, VR0, which is here, VE, which is here. Okay? And then what we have is, right, VRC2 is very simple, right? It's just I test RC2, right? For this one, it's also pretty simple. It's just I test minus GMVB. Right? So the total current going here, right, I deduct, I get the remaining current through R0. So I multiply by R0 here, right? So this is the, right, this term over here, this one. And then for this one, right, it's actually just VE. So in the end, you agree that both current that go into here combined become the total current that enter through all these three, right? These three branches. And these three branches in parallel become one big resistor. So the total current in this one big resistor is actually just I test, because it's all in series, right? This is series with this, and this whole thing is in series with this, right? So the I test going down, right, will go down through these three nodes, right? These three branches. So I test multiply by these, right, branches in parallel, right? Makes sense, right? It's just one big resistor. Okay, and then right from here, right, it's just math really basically, right? So VBE, right, I can express as, or sorry, this whole thing, right, I can express as like that, right? So this is VRC2, and this is VE, and then this is, right, VR0, right, which is over here. So this is VR0. Right, I open VR0 only, and then this one you understand, right, this part. Right, here to here, right, here to here is also the same thing. Here I just do factorization only, right? 1 plus GMR0, then I take out VE, right? So this one I bring down here, and then I bring back all the value inside the VE as well as VRC2, and then here I'll just, right, divide, just not say divide, but I get rid of the I test like that. Okay. So in the end, it become RC2, R0, and then this whole thing bring down like that. And then I get this value. And then once I get this value already, I can calculate, right, R out equals to R prime out parallel with what? Not RL. It's RC1. Okay, what is RC1? RC1 is 150K.
RC1.
So our answer will get 137.587694.
RL is from here to here. RL doesn't come. RL is from here.
Okay, question 2 done.
RL will not be constant to RL. RL is variable.
RL, you take out RL, you look what's inside RL. Like what RL see? What the load resistor see? It sees what resistance. That's the RL out.
So还有 green tea 和 honey
Oh, we haven't finished the small signal input yet. That's 3 marks only.
Yeah, what is the value?
137.
137 mega.
Oops. 1 kilo. No, the answer is here. Let me go and get the criteria.
You added the milk to it. It looks very diluted.
Correct. Because I don't do it.
Oh, okay.
最后的 T 根本很好。
Come on.
You go cook it off. You put onto a printer set to 60. Good job. Criteria only to find small signal. Small signal, how much point?
2 marks.
3 marks. This one can ignore.
Nice.
Small signal is 0.2.
You remember just now we calculated the VBE and VI? Correct? Why? It's actually one of the easier questions. So VI, right? 5 millivolt times, right? VBE over wrong. VI times VBE. Okay, then very simple. We just find what is VI over VBE. We should actually calculate it earlier already, which is over here. This one. Okay, so what we need to do is just calculate the VBE over VI, or the other way around also can, whichever floats your boat. So negative 1 over Ri, which is 100. Actually, don't need to negative also can, because it doesn't really matter. RE1 is 131.6 kilo plus 1 over R pi, right, plus GM over Ri, which is 100. Okay, so I inverse this times 0.005 millivolts. Wow, actually the signal very small. Is it correct? My answer is super small.
Wait a second.
Did I add correctly or not?
What does that mean? 5 millivolt times VI over VBE.
Wait, let me check my answer.
What does that mean?
Oh, use wrong calculator. Bro,
What do you mean?
the value I stored in this calculator, I go and use the other calculator. Now I was like thinking why the value different one. RE1 is 131.6 kilo plus 1 over r pi plus GM. Oh, very good. Okay. Inverse times 0.05 plus 0.05. Why it's 40 volts? Eh?
Go back. Actually, power is also
You all get the same answer? Oh, no one doing already.
my computer dying.
Everyone give up already.
Computer dying.
We haven't do last question. Eh?
Oh, yeah. Time's up. Bandung.
Yeah.
Just one.
Actually, last question, I think.
This one.
Wow, last question a bit long. Eh? Cannot. Got this already.
Yeah. How you get the VI or VB?
We actually derived it already.
Well,
Over here. You got it already.
as in why VB turn into VI, then you add one more VI.
No, we.
Yeah, how?
No, here I multiply here, ma. Like I multiply on both sides. So if I multiply on both sides, if I multiply this by here, right, I actually get VI, ma. So I just need to multiply like that. Then the answer should be 40. So I can input a maximum of 40 volts.
You multiply VI over VB.
Quite high actually. I don't know whether that makes sense. I calculated correctly though.
Yeah. Can check the search history.
This is VBE over. So inverse. Yeah, 40 volts. Yeah.
I thought we should get VB for one.
Don't know, I get 40 volts.
Wait, how do you do that? Just straight up. Huh?
Hmm?
Just VI over VB. But we get. Some we get what? VB
As in, we didn't calculate that value out lah.
Oh.
Okay lah, we go to the next question lah.
Huh? I don't understand.
Huh? Which part?
VI over VB.
This here. We already calculated just now.
We just invert the I over.
Yeah, just invert only, then we get answer already. Yeah.
Is that
Kind of.
Wait, I see. How you turn VB to VI? You say time VI. From VB. Oh.
Make sure that the modulus over the VI because the signal can go positive and negative.
So it's modulus everything. Absolute everything.
Yeah. Derive expression for omega L and omega H.
Fine.
So there's only two capacitors actually, so shouldn't be a problem. This one contribute to omega what? Omega L, omega H. Is bad for low frequency or bad for high frequency?
Which one? CR.
C might.
So you might bad for low frequency.
Very good. Okay. This one is bad for?
Because it blocks low frequency.
This one is bad for what?
EF. Still high frequency.
Yep.
Why?
Because it allows higher gain. Remember your gain?
Oh, okay, yeah.
Your gain, right, is RF over. So on top it is is it the other way around? Let me see.
RF, yeah, you higher frequency and your the RF side become higher, then you get more gain there.
Should be lah.
Wait, but it's different on my circuit though. No, this
Is the CF contribute to low or high frequency?
contribute to low eh.
Low, right?
Yeah, low.
Should be low, right? Then we write low lah.
Yeah, low. Sorry. Low for what?
because if it's short, then it's supposed to reduce the gain. Yeah. So we need to derive expression for omega L and omega H respectively. Okay.
That means omega H is just 0.
It's a low pass filter, right?
Yeah, low pass.
Sorry, high pass filter. So it's actually like that. Something like that. Like that, and then like that, and then like that. Yeah.
Oh yeah.
So let's do C mic first. So C mic, if we do, it should be everything open circuit, right?
What do you mean?
OCTC, right? Open circuit test, right?
Oh, OC is open circuit.
So when you do open circuit test, C mic, the R mic, right? What do we get?
C mic R mic you get 0.
No, it's just R mic plus RS.
Oh, you see.
RC mic. Okay. And then for RCF equals to
RF RI. RF plus RI. How do you do it? No RF.
ground, everything ground. Here's 0 volt, 0 volt.
Yeah,
So it's just RF lah.
RF.
RCF what? Here is 0 volt, here is 0 volt. Correct or not?
Oh, just one you mean.
Should be just RF lah. If I'm wrong, then anyway, this is not exam paper.
I don't know how you know what resistor.
Omega L equals to what is the is it sum or just adding? I think it should be the sum.
1 over C.
Then we go here, right? Where was it? Too high already. It's somewhere below. Yeah, it's below. So omega L is you add separately, right?
Yeah.
Equals to 1 over C mic RC mic plus 1 over CFRF. Okay. Just derive expression only. Okay, like that. Oh, actually, I just need to write the full thing.
Do we need? Oh. No, we don't need now.
Okay. Show that VI over V mic equals to A1 T1S T1S plus 1 or D4, and by deriving expression for A1 and tau 1. Okay. Can, very easy. So what do we need to do? Where's VI? VI is here, right? And V mic is here, right? So we just need to do what? What's the thing that we need to do? Oh, you forgot already.
Actually, I never go through this yet.
Just convert to S domain lah. There's S here what? S is the clue here is S domain.
Oh, forgot. Did they give us last paper?
This is super. This one is 3 marks. How many marks they give you? This is just a simple voltage divider only. How much marks they give you? Really like it. It's 8 marks. What the heck? Why they give so much marks? Just voltage divider. VI.
There's a catch.
VI equals to, right, it's the total current that go down here, right? Okay, it's just RS divided by, right, RS plus 1 over SC mic plus R mic plus, it's just this lah. Then here is V mic. Then after that, VI over V mic equals to, let's see how we can make it reduced. We need to multiply by everything. Okay, yes, looks right. Okay, I need to multiply by S. Yeah, correct. Okay, but because the RS makes a bit looks a bit confusing. Okay, so I multiply by S, R, S, C mic divided by S RS C mic plus 1 plus S R mic C mic. Okay.
That's it.
I just multiply by S R C mic.
Oh,
Let me see. Oh, actually, okay, let's see this part first. We need to convert it into A1, right? Then ST1, right? ST1 plus 1, right? Should be like that, right?
oh, it's TRC. Oh, okay, yeah. Yeah, then you have it already.
Okay, yes. Our tau one should be actually, remember, our tau one should be R mic plus RS.
One should be plus
Correct actually. 1 plus SC mic, right? Is RS plus R mic, right?
Yes.
Which is the same as our on top one. Yeah, R mic R plus RS. Yeah, correct. So what we need to do is, since our tau is equals to C mic RS plus R mic, right? So we need to somehow convert this into that one, right? So what we do is our A1 is actually just that, right? So what we need to do is we need to multiply by RS plus, oh sorry, actually the other way is multiply by RC divided by RS plus R mic multiply by S C mic RS plus R mic divided by 1 plus S C mic RS plus R mic. This tau 1, this tau 1, this A1. If can, that means correct.
The top is SRC.
Wait, what do you do in between these two?
From here to here, I just divide by. So okay, so I want to get from RC, right? Suddenly become RS plus R mic, right now. So I need to divide by this one. Then this one I just put here only. You know what I mean? Just to convert. But in the end, these two is the same. Cause in the end, these two will cancel out, right now. Then RC times this one.
Yeah. Where RC come from?
This one come from here. I here no RC already.
But there's no RC on the first equation.
Wait. Oh, I type. Yes. Good. Type right wrongly. Just it's just writing. Yeah, good.
You get something like other stuff and like how
Not this one. Okay, so what we're trying to do is we're trying to get the time constant for that particular like portion, and then we know that our time constant is this one. So at the bottom we already have the time constant, right? Which is like that, right? All along we have it, but the top we don't have. So we need to somehow convert the top, right, to be the same expression as this. And in order to do that, we just need to divide by the one that we need here and multiply by the one that we don't want there.
Oh, okay.
Yeah. It's like to get rid, like to convert it.
Laplace.
Yeah. So that's how we get this. You're asking how we suddenly get this here, right? This one? Or this one? Oh yeah, this one is taken from on top. From here. Like just now we calculate the omega L, right? We know that we want it to be this. You know what I mean? Yeah.
Why this question got such more points?
8 marks.
Yeah.
Good 3 marks though.
People who don't know die. So I think your iPhone got piece. There's a water coming onto your spec.
Oh. Sorry. Oh, sorry. English speaking. Okay. Actually, the CF might have contribution to the low upper frequency also. I believe. Yeah, I think it's.
It doesn't gain for the high frequency. It only gain for the low frequency.
No, I think it gain for the high.
Because at high frequency, you want short.
No, I think in between it should be in between. But we calculate first. We calculate first.
But anyway, at high frequency, the thing will not have gain.
We try first. We calculate part C. If we calculate part C, because part C got two time constant.
Oh.
So we can calculate that. Okay, so V out over VI, right? Okay, so VI. Okay, actually they make your life very easy. VI. Okay, so how we calculate? V out equals to what VI, you know? So if you have VI here, the current going down here, correct?
Okay.
Right?
Yeah, okay.
So it's actually just what? VI
1 plus E parallel F over R.
Can?
1 plus.
Oh. Yeah, need to plus VI. Yeah, you're right. Yeah, because this is VI. Okay, so is equals to, right, this one is RF over SCF divided by SCF plus RF over RI plus 1. Looks a bit messy, but you can do whatever way you want as long as you get the same expression. The on top multiply below plus ma.
Oh.
Okay.
Plus 1 equal to RF.
What's the expression we're supposed to get? We're supposed to get A1, then something plus 1 below, is it? Oh, everything plus 1 there. interesting. So it's A2 tau 3 s plus 1. Okay, divided by T2 s plus 1, right? We're supposed to get this.
Find A itu RFI.
Okay, so now we have this first lah, right? But we know for the fact that this is one of the time constant.
Yes. Does I come together with the time constant?
Sorry?
The RFI. CFR, is it we count only CFR or count all three together?
What do you mean?
The two resistors need to count together or only count RF?
Later. Yeah, but yeah, this one, these two. Short circuit. Zero. Okay. Plus 1 is just what?
1 plus SCFR.
Okay, I know to get the one already. So it's RF divided by RI, right? Plus 1 plus SCFRF divided by 1 plus SCFRF. Okay. Is there a careless mistake somewhere? Who's right though? And analyze from the top again. So from here, VI, right? These two in parallel make sense over RI, and then plus 1, right? Because of the voltage VI, right? And then these two multiply together, we get RF over RCF. Okay. Then these two add together, the bottom divided by RI, and then plus 1. Okay. Then after that, I multiply by SCF, which I get on the this one become 1, this one become SCF RF. On top is just RF. Then these two multiply together, then this RI still stay the same. Here happened. Where we get the yeah. So this one divided by RI, right? So RI here, then here RI. Now there's no careless mistake, right? Then plus 1 on the right side. So it's actually R here to here, here to here, then divided by the same thing. So we divide everything by Ri on top and below. So Rf over Ri plus 1, because Ri over Ri is 1, SCF, right? CF Rf, then divided by 1, Ri same thing also. Like that, okay. But now we have some issue, right? Because this one don't have the S factor, right? If you have S factor, then we actually can close already. Oh, I think maybe we are actually we might be super close actually, I think. Are we? Is this correct? Oh, I think I just need to put 2 RF over RI, right? Then I bracket the whole thing. Then become 1 plus S CF RI over 2. 1 plus SCF RF. Like that.
Huh?
This one we know is tau 2, and then this one we know is tau 3.
Oh.
Then this is your alpha 2.
Okay.
Yep.
The I over 2 should be RF. 2 RF.
But then the 1, right? The 1, the 1, wow. The 1. No. I thought so annoying.
Thing is broken.
Oh, I think I have to divide by the whole thing. Oh, yeah. Okay. If I divide by the whole thing, then become 1. Yeah, correct. Yes. Yeah, correct. So it's equals to RF over RI plus 1. Like that. Then that is correct already. So RF, so on top here is just RF or divided by RF over RI plus 1. Or. Yeah, like that.
But then the
So cancel out. So this one is actually just 1 over RI plus 1 over RF, which is actually just RI and RF parallel.
no wonder so much point.
Oh, I think this must be correct because just nice we can get very nice. Because RI and RF parallel. Wow. These two parallel, which contributes to the upper frequency.
Oh. I still don't get it.
Oh my goodness. So our answer, right, for the top, which we actually can bring back. So we can derive the omega h, right? It's actually 1 over CF RI parallel RF. Done. So we now we know this answer is like that is correct. So we have three 3 points, right? 2 omega h is considered as zeros, I think. Then omega h is poles, right? I forgot already. Either one. Yeah. Okay, so now we got the expression for omega. So now we can go back to question part A, right? To get omega L and omega h. So omega h not so intuitive, right? Like originally. Yeah. That's why I was thinking it actually contributes to both, right? So somehow, right?
Does it contribute to both?
Yeah, because as in between, so if you block the low signal, not so good also. If you block low signal, it's infinite resistance, infinite gain, but low current. Yeah, whatever lah, but you get me. I think yeah. It cannot be blocking because that makes sense. So for low, right? It cannot be blocking low also because when it's low, right, actually it's good for low also. It's good for low because the impedance increase, right? Correct. As the impedance increase, the voltage is higher across. Makes sense, right? The voltage is higher across. But as you increase the frequency, then become short circuit, it's also bad. So it's bad for both sides. So it's only in between only. Open circuit not good, right? just now we agree, that's why we got omega L, right? Oh, sorry. Omega L means open circuit not good. But yeah. So open circuit not good, short circuit not good also.
When you say contribute, what does it contribute mean? Does it like block or
Block. Contribute means blocking. Yeah.
Oh,
So it contribute both.
yeah, this one block nothing.
Hmm?
Yeah, CF block nothing.
Yeah, high frequency not good because basically there's no gain. But low frequency not good also. Low frequency then
You just give RF to pass through.
yeah, you just R pass through. So you want yeah.
That means people.
Okay, so now we got these two expressions already. Hence we can write V out over V mic by matching omega L and omega H found with their time constant T1, T2, T3, catch the boat plot. Clearly mark the location of the two pole frequencies. Okay, two pole frequency basically means is the zeros lah, right? Sorry, the pole frequency means the omega L. Zero frequency is omega H and net gain A1, A2. Okay, so we can get the A1, A2 first. A1, A2 already have it very easy. So A1, A2 is RS over RS plus R mic. Okay, then this one is RF over RI plus 1. Like that. Okay, so once we have this, we can draw the pole and zero frequency. Okay, so we draw the body plot. Okay, like that. This one is omega, and then this one is in terms of gain. So the gain is AV, right? I think, yeah. Right, which is actually just V out over V mic. Okay. And then we need to have what? Clearly mark the location of the two pole frequencies. So I will mark one here, and one here, right? So this is 1 over tau 1, 1 over tau 2, 1 over tau 3. Okay, tau 1 is what? Yeah. So it's actually equals to 1 over C mic RS plus R mic. Yeah, I remember already. This one is 1 over, this one is shorter, 1 over CF RF. This one is 1 over CF RF parallel RI. Okay, and then we have here, and then it goes down, and then it goes down here, and then it goes down. Down some more. The amplitude is just A1, A2. If I'm not wrong, it should be. Yeah. Because that's the maximum value you can go at. If I'm not wrong, yeah, maximum value you can go. Makes sense, right? I think, yeah. Yeah, makes sense. Done. Finish. Just nice 2 hours, right? I think. Or a bit more than 2 hours. We went through so slowly.
This one is 40.
I'll check with Dr. Didier this is correct. I think should be lah. I quite happy with this one. Seems very correct.
And this one only got 1 line, so 1 point, so it's just plenty. This is a bit different from like what.
The understanding, as long as you understand.
The back part is just 20 dB per decade.
Yeah. I anyhow draw the slope one. I don't go and copy until look very.
And go through a MOSFET question. MOSFET 有麻烦。
MOSFET even easier actually.
Because he never cover much. So we
Okay, what exam paper you want to go through for MOSFET?
what question number?
You go and find again, I go first.
I don't know. Like,
The one is the one
you went through, is it? Is it?
this one is the paper he went through. So try another one.
Go to NTU learn, take another piece. Or actually, is the Oasis question hard, like the challenging Oasis question? Is it?
I don't know.
Try. Go Oasis and see the question there. Is it like a lot or quite challenging? Then if like then we can go through. Not. Where? What content? Have you seen the band pass filter before? Okay, so it is like that. It's just like that. When there's omega L, right? It will drop the passing omega L will drop the gain. Then got more, then it drops more. It's like that. The shape is like that.
Analogy. Small signal CSEBCG.
Those are common. Those are DJTs.
Differential M. Differential M.
往下走，还有 MOSFET。
MOSFET
current mirror 没有。
没有了。multi-stage 没有出。MOSFET biasing DP analysis。
喂。没有了。
Hello。
This is what common source.
Kind of very easy, right?
Bring like.
What other people the MOSFET one? Or you want me explain the MOSFET on this one? The past paper or another question or what? Or you want to do another
You
one?
want to explain the yesterday one?
Or you want to do another one?
I mean, I only have that question also.
Yeah, then we
Only
explain.
have the question.
Yeah, we never print out the.
Yeah, maybe I start the podcasting first. I go and find the paper. Find one paper. So it's EE2102. Only got one right from there. So I try EE2002.
But in terms
Oh,
of
this is the one I did, right? Yeah, this one I did.
MOSFET gate have no current.
Actually, I think everything else I already done already. Last time.
Last time is 5 question time.
4.
So we went from 5 to 4 to 3. Then the future will become 1.
But MOSFET and the BGT is actually the same, you know. Like the calculation, everything is the same. It's just the VGS.
VGS is 0.
Yeah, there's no impedance there. It's open circuit. Then if you actually should be easier though, depending on how you
I
do.
only know it doesn't have uptime, but I don't know how to get
Not an GMV VGS or what.
all those parts.
I think it's just the analysis. Don't even have current mirror. Last time got current mirror, you know. Then you need to multiply with the what?
You see, when they say they don't have current mirror anymore, right? Our assignment 3 is current mirror.
Really? Oh, so that at least you learn primary lah.
It's like voltage buffer like that, but then it boosts the current. No?
Oh.
Yeah, it's a on-amp buffer, but then it just supply more current.
Oh, you still want to go through?
Study go through, or you study explain how
I use this one lah. Lazy a bit.
yesterday that one.
Yeah. Okay, and then let me open the Zoom. Where's the Zoom?
Should I go some stand over?
Oh yeah, my Zoom is here.
Still
Yes. Okay.
Yes.
Okay. Now we can see this, right? Okay, so for this one, actually, let me open the laser pointer. Okay, very good. So you see this circuit, right? So first thing we calculate Q point, right? What do we do when we want to calculate Q point? DC operating point, what do we need to do? Capacitor become open circuit, okay, and then oh sorry, let me answer a call first.
Okay.
过去了。
Oh, okay. Okay. I can go down to cable self search. Yeah. you. Okay. Ready?
Yes.
Let's go.
Okay, so for this, right? Okay, use this one. Okay, so we need to open the capacitor. Okay, we open the capacitor. So what happens is we short the independent sources, right, to ground. Right, so here is ready to ground. Here this is shorted, right? DC is open. This is open. Right, this is open, and then here is open. So open means we need to include R2. Right, so for the next part, right, we open the capacitor. We have R1 and R2, as well as the MOSFET, right? So you can draw the DC operating point like that, or DC operation. Right, VSS actually is supposed to be ground here. No, sorry. Here is still VSS, right? Okay, then what you need to do is remember what's the next step after this? Okay. So you find the right Taiwanese equivalent. So for Taiwanese equivalent, right, over here, for Taiwanese equivalent, right, we combine the R1 and R2 correct now. Right? Because you see, we want to find the Taiwanese equivalent from gate to the ground, right? So we can draw something like that. Right? I didn't really do anything different. Just R1 and R2 combined become RTH. So VTH, what do we do? VTH is actually just the voltage at the gate, right? When we do a voltage divider for R1 and R2. So basically it's just this, right? VTH equals to the VSS multiplied by the voltage divider. And then we can get the value, right? VSS, right, is given, right? VSS is 15 volts. And then R1 is here. R1 is 3.23 mega. R2 is 5.5 mega. So once you put the values inside already, we can get a VTH. RTH is just the two parallel. Then we can get the resistance RTH. Okay, that should be it actually. You don't understand, right? You want to try calculate. It's actually the voltage divider that you've done before actually. You can take some time to look through this.
The only thing different is the gate current.
Yes, the gate no current. So later we'll go through that part.
没有 pass， 没有 pass， 没有 entrance。出来了，回地了。Normally, this thing is just a MOSFET.
Yes.
Can you write on it?
No. Okay, you can try to convert the circuit yourself. That means from the main circuit itself, right, with the capacitor and everything, the circuit that they give you in exam, right, or exam paper. Try to get this yourself. If you can get this yourself, then at least you have some confidence, right, to be able to like be able to do the DC equivalent. Because this one actually gives you easily, I think, few marks really, right? I'm not sure how many marks. I think 5 marks or something, but it depends on the exam. Yeah, this DC point the Q point, right? Q point you get the value you can get already. Okay, so most importantly is be able to get that first, go there first. This one you should be very strong, right? Be able to do it very well. This one should be something that you should be very, very confident at. Okay. How? Everything okay?
To find VGS. VGS is VSS minus IFRS.
So you want to go next one already? Or yeah. Okay, so when we find, so what we do is when we find the Thevenin's equivalent, right? What's the next step for finding the the DC operating point, which is known as the Q point, right? Crescent point, is actually to find the ID as well as VGS, correct? Or VDS, sorry. VDS and ID. So basically, right, what you need to do is you always need to find the voltage across the inputs and output, right? BJT is the same thing. You know BJT got VBE, VB, got base, got collector, got emitter, right? It's always between the collector and the emitter, VCE, right, or VEC, depending on NMOS or NPN or PNP. In this case, right, it's MOSFET, right? There's a gate, source and drain, right? It's always between the source and the drain. In this case, it's NMOS, right? Sorry, is it N? Out in this one is PMOS, yeah, PMOS. So for PMOS, it's between the drain and the source, right? So they ask you to find what? They ask you to find VDS, right? VDS, right? It's always between the source and the drain one, always. So to find VDS, and then it's IDI, it's always the drain, right? For MOSFET, for BJT, is what do you find? For current, is always IE. It's always IE, correct? B, C, E, and IE, right? They always want this. For this one, it's ID. I said correctly, right? IE, right? It's always IE, right? Okay, I never say wrong. Okay, so assume MOSFET saturation. Okay, so assume MOSFET saturation means what? Means operational, right? Means it's operating. So ignore channel modulation effect, right? So that one is just the formula have channel modulation and no channel modulation, so you just ignore. So that one don't really think so much, just always ignore. In this case, usually it's ignore. So we have the circuit, right, from just now, never do anything, right? So what we need to do is we want to obtain, in this case, we find one of the value first, right? We either find VDS or ID, right? So I think finding ID should be easier, right? So what we have is VGS is where? VGS is here. Right, so it's basically going down to the ground, right? Correct or not? Right, we know this, right? This is the path we know. Okay, this is the path we know. So from VSS, multiply minus this voltage, or these two voltages, right? So ID will be passing through here. Do you agree ID will be passing through here? Why? Why is that so?
Yes.
Here is S though, why is it ID?
Same series.
Because nothing goes in out of the gate.
Yeah, so nothing going in out of the gate, right? The current that passes down through this into the source, right, must be the same as the one going out of the drain. Because there's nothing going in and out of the gate. So IS equals to ID. So in this case, I just wrote ID lah. But actually it's just IS equals to ID. Right? So it's just ID. Because in here you're looking for ID, you don't care about IS. But it's the same. So the VSS minus the voltage drop across these two resistors across VGS, right? Correct. Yeah, across the VGS. Then is equals to VTH. There's no voltage across RTH because there's no current. Okay, so actually at point G, right, VG is actually equals to VTH. Okay, so we can get this expression. And the reason why we put modulus is actually it might be negative I think. But it doesn't really matter as long as you can calculate VGS. Okay, can follow with this KVL expression. Can. Okay, and then from the formula we can substitute, right? So in this case, right, there's two methods, right, to do. One is you do ID as a simultaneous equation, or if not you do VGS as a simultaneous equation. Usually sorry, not simultaneous, quadratic equation. Because usually VGS is easier because you can just plug in like that, then you can go and calculate. So in this is from the formula, right? You plug this inside this ID over here. You know what is VTH, you know what is these two, and you know VSS. You don't know what is VGS. VGS is unknown. So far everything here, right? The only unknown is VGS, correct or not? ID you're going to substitute inside here, so ID will disappear. KP is given as negative, just 1 milliamp per volt square, right? So actually you can just substitute inside. VTP is also given. Okay, I just substitute inside. What happens is, right, I just substitute inside me, then become like that, right? Just multiply by this. Then minus VTH, I just brought it to the front. And then what I get is, right, this expression. I just do some manipulation here and there, right? I find the coefficient of VGS square, I find the coefficient of VGS, and I find the constant term equals to 0. And this is actually a quadratic equation. Quadratic equation. And this quadratic equation, I just need to solve for VGS and can plug inside calculator, or you can do the negative b plus minus square root, right? B square minus 4ac over 2a, that one.
VGS is X.
VGS is X. Yeah, VGS is unknown.
VGS. Oh, okay. G to S. Oh, okay. Yeah. Oh, this one is send us also. So that's what I KP. Have all the questions be consistent with this one?
Yes. It's more or less like that. It's just the values different only, and maybe the terms different a bit. But it's always solving for the quadratic equation.
I haven't submitted yet. You didn't submit yet. Question 1. Question 4. Question 4.
Afterward, you just solve everything out. Seems like it. Wait. No, your final line, what does it? VGS and VTP. I lost at the final line.
It's just manipulation actually. Yeah. Like all the right side term I bring to the left. That's why everything else on the right becomes 0.
One by one, do one by one. Step. How we know 1, 3, 6. Like how we do one.
so cheap. EGS square minus. Oh, okay. Oh, you open it up. Then afterward, you use quadratic equation.
This one is just a little bit more tedious than it's actually difficult. Yeah, a bit more tedious only. Just don't mess up the manipulation. That's all. Yeah. Actually, what you can do is, you can just get the numbers that's associated with each term, each unknown term, and then you just combine all the numbers together. Also can. But this one I just did derivation all the way, so that you can just plug in the terms easily lah. So it really depends on how you want to do it. But this is just for practice lah. I mean, it's good to be able to manipulate this. It's not really tough. It's just a bit tedious lah.
Okay, let's move forward.
Okay, right? We haven't even touched the small signal model yet.
That's more easy. Okay. 1 minus.
You're doing the manipulation, right? Correct.
Wait, I don't understand where the 1 minus comes. Where the 1 minus comes from?
The 1 minus?
Yeah.
This is VGS term, right? This here, this is where the 1 come from. Minus this one times this one. Correct or not? Because here got VGS term, and this 2 VTP times this one, so the 2 can cancel out from here. VTP times this one, and then RS1 plus RS2, then VGS is here lah. Like that, that's all. I mean, if you do it, then you can, for my working, sometimes you don't do it this way, but in the end, you should get the same answer lah. You understand what I mean? Sorry? Yeah, you can put in number also, can lah. Yeah. But it's a good practice lah. I mean, this is not too difficult. It's just long only. Just long only. You have to write so long.
I try to manipulate myself. This is going to take a while. If the VG is what?
It was.
我在了解这个感受。Okay, so I got ESS. KPO2 RS plus RS. EGS square minus.
Oh, yeah.
Yeah, this one just math only.
Question 4 is hard, but it doesn't make sense though. Not for that distance. I don't calculate the distance 30 minus 10. So actually it's
Trying to understand where that is go. Yes, minus. Okay. Yes.
Yeah. First question is 1.6. Second question is 4.5. Question 1.
Oh, okay, got it. Yes, very nice.
Can right? Very easy, right?
Huh?
That's my catchphrase now. I realize I've been saying that a lot. Not easy, mate. It's just very simple mathematics only.
Yeah, same nice.
Then you need to practice more.
I need to underload. Very nice. Got it. Afterward, you sub all the number in. Then you get ID. I'll go toilet first. I pass. Oh, step back.
So now you wait very long, you won't die. Oh no. Is it because it's nearing exam, everybody getting sick?
No, it's because I sleep too much.
What? I got such thing as sleep too much, man.
After a long period of sleep deprivation, but suddenly one day you can sleep like normally.
Then after that become got problem.
Yeah, problem one. The change cannot be too drastic. It's because yesterday I need to catch a early hitchhike for my friend who come here to school. So I woke up at 5:30.
Oh.
So yesterday I slept like 8 hours, 7 hours, 8 hours. Cannot already because usually I've been sleeping at 6.
Wow. So I cannot sleep too much.
But the lack of sleep making me downward.
You don't enough sleep.
Long term sleep. Yeah.
You know, I long term not enough sleep, right?
Isn't that good?
Yeah. Then but you wake up not so energetic.
I thought
Yeah.
it would carry forward.
No, it doesn't carry forward. System not linear.
Yeah, right.
Let's go. Let's continue to the next phase. So I need to.
One second, hello, yeah. Wait, oh.
Oh, this part. Okay. Okay, so now what we need to do is we calculate. Right, once we calculate VGS, you all calculated already, right?
Yeah.
You can calculate ID or not? You manage to do that? You all get the same value? Okay. Okay, so we got the same value already. What do we do next? Okay. What do we do next?
ID. So we got the Q point.
Okay, once we got ID already, we find VDS, right? You all find VDS already? Remember the Q point, right? We need to find these two values, right?
Okay. Oh yeah, VDS. VDS is okay. Absolutely okay. So now
Okay, this part done. Okay, so it means that it is in saturation mode, right? Okay, so now we need to draw the small signal model. Maybe from the circuit, right? Can you draw the small signal model? Can try yourself first. So small signal model, what do you need to do?
Same as BJT without the up.
Same as
BJT.
BJT without the up. Yeah, similar. Okay, so the arrow pointing where, just try to draw. So the capacitor must be short circuit, open circuit. Okay,
Sure.
so the capacitor must be short circuit.
Okay, so I assume capacitor short, that means this is common. No, this is common. Common gate. Common gate. So we should get the same circuit as just now.
Yeah, it's such an easy man.
Plus minus RI. R1, R2 doesn't matter. Then it's R1 to R2. Like that. Let's check.
Yes.
I am very wrong. What is this?
No, why? Can be correct also. What?
Okay.
Have to see lah. Have to see. But it's here. What? Oh, you looked at the lecture now. Okay, sure.
Yeah, it's in. Different than the 140.
Yeah lah. I mean, I can draw differently, but
Yeah.
in the end, if it's still the same, it's still the same lah.
This one is. Yeah.
What's the base?
Yeah, that's our common. Yeah, so I said my one should. Oh shit, that is not okay. Yeah. That line. This is drain this source. Gate is open though.
Okay.
Yeah.
Can get lah.
And
It depends how you draw. Actually, my way is just really like a certain method lah. It doesn't really have to be that way. As long as you can get the answer, it should be fine.
this is PMP. P is P minus. So this should be D and S should be D. Equal to S and G.
Okay. So I go to the next part. So we get this already, right? We got this, right? Can, right? This is what we have. Okay, don't have to be exactly like that. The drawing don't be like that. It can be another way. But this is just the way I have it lah. But this may be more confusing, but this is what I already drawn lah. Yeah, but it's the same, right?
Yeah.
Can. Actually, this is the one that we similar as the other, the BJT one. Very similar, right?
Yeah.
Actually, almost the same.
Just R5 got delay only.
Yeah, then okay, what do you do now? Go and calculate the
ABP.
before that you can calculate the R0, right? And GM. Get free marks lah. Get the free marks. This is free marks. Easy to calculate, get free marks. You already got the Q point, right? Once you get the Q point, just plug inside.
So far, not fine. Not GM. What's the formula for that?
The formula is here. Just try not to copy the answer. Just see first.
See where they're ready. Very good. Yeah. 1 over lambda plus BDS over GM is Wow. 2K PYP 1 plus lambda ETS. Lambda is 0.015. BTS become. So we know how to apply BTS. BTS is 2.397. Times 1 MT plus 1 plus alpha BTS. Chẳng có mấy 5752对了，诶，哦，那给我的，对啊对啊，所以就是that many decimal point。为啥好这样？Oops。1.57 Yeah, got it.
Okay.
PM is Siemens.
Siemens, yeah. It's an inverse of ohms. Okay, so now what do we do next?
Now we find terminal gain.
Okay, so now we find the terminal gain, right? So for the gain, what do we do? V out we can ignore, right?
RO.
Sorry, not V out. Yeah, R not we can ignore, right? Then we can express AVT, right?
Yes.
So how to express the AVT?
It's VD over VS.
Right, it's actually right. In this case we are looking at the output,
Over the
right, to the VS, right?
Yes.
Right. So from here, how do we get from here to here, right? Is remember, in this case, the current ID, right, like going out this way or yeah, whichever lah, in this way, okay. Then this is RL prime. This whole thing is RL prime minus VGS, GM VGS, right, which is actually ID lah. Okay, multiply by this, which is actually a VD. So you can see current times total resistance is the voltage, which is VD, right? Correct?
RL prime is RD parallel with RL.
You can see
Okay.
right? The current at D multiplied by this whole thing is the voltage, right? And the current is GMVGS.
Yeah.
So on top is GMVGS multiplied by this over negative VGS, because VS is actually negative VGS ma. Correct. I can cancel out the VGS term. Okay, then become GMRL prime. Can, right? Then I redraw the circuit again, right? Basically, this whole thing is R in, right? You can see, right? So how to get from VI or input voltage to the VGS, right? It's just a voltage divider. R in voltage divider with RI, right? The input resistance. So like that. So the gain is actually AVT, which is just V out or VD over VS, right? Whichever you want, right? Over R in, right? Which is this R in, the voltage, right? Multiplied by R in plus RI. Can see, right? R in and RI, yeah. So it's VI.
Oh, VS to ground. Okay. Let me just jump this one down.
Okay.
If VS there, right, the VGS part got a resistor there.
Where?
If this part got a resistor there, right, then means we have to count RS1 and RI.
Wait, which resistor?
Yeah, is it? Yeah. Because right now VS is just short to ground.
Yeah.
This part never count, right?
Short to ground?
Yeah.
Here?
Yeah.
Here is not short to ground. The current will have to go to the S, then come down here, and these two branches.
Okay.
Yeah. Oh, yeah, that's all.
VS is negative VGS.
Yeah, correct. VS here. Here, VG is 0 ma. VGS equals VG minus VS. So it's minus VS. R in. R in is this whole thing. So whatever you see from, so you remove RI, whatever you see from the RI side, so it's RS1 parallel with everything. That one. Okay. Okay. So this is another method. You can ignore this part lah. Okay, this is the input resistance part. We can also ignore R naught, right? Ignore R naught. Okay, ignore R naught. To find input resistance, we find R in, which is just this part. And then we see the S and CD, everything. Then we just do a test voltage, right? And test current. So from here, right, we know the current is what? We know the current has to be GMVGS, correct or not? It's confirmed one because there's only one path, what? Correct or not? So this is the current, right? But whatever the current produced, it must be negative because the current we're seeing is out. So it's negative VGS, right? GMVGS. And then we can separate it to become like that, right? Correct or not? Because VG is 0 ma, so it's like that. You see, right? V test we can just set as 1 volt, for example, right? Doesn't really matter, right? But anyway, right, the negative VS it will cancel out. Can see, right? Then VS is actually just V test. Okay, it's the same. So can cancel out, become 1 over GM. Okay. And then once you know that the input prime, right, resistance is actually 1 over GM, you can just parallel with RS1, you can get the answer already. Simple. This is simple one.
What?
Huh?
R
R in prime, which is 1 over GM, parallel with RS1, you get the total R in. Makes sense, right? Okay. This one should be simple lah. You buy it.
Why your VS turn into VTest? Negative VS.
Because here, right, is negative VS, right? But it's the same thing as me connecting the test voltage also. You know what I mean? I'm plugging in. Okay, yeah. Happy, yeah. Easy, yeah. Maybe need more practice.
No more practice, I don't understand the theory.
Okay. So finding R out, we need to include R naught. Right. So for R out, we exclude the RL obviously. RD in this case we can exclude first because we want to find R prime, right? To reduce our calculation. So in this case, what we see is the GM VGS in parallel with R naught and then everything else, right? These two RI or R input and RS1 is in series parallel. So actually there's two parallel terms and these two parallel terms. And once we see this, and then there's a dependent source, what we need to do? What do we need to do when we have dependent source? Yeah, we need to find the Thevenin's equivalent because we need to inject, right? Because we can to find the Thevenin's equivalent or Thevenin's resistance, right? We cannot calculate without injecting a test. So in this case, we inject a test. So R out prime, right, equals to V test. Okay, so V test over I test, right? So I'm pushing it through here without the RD because it's in parallel, so you can just read out first. So it's actually equals to remember just now the voltage across the R naught as well as the voltage across these two in parallel, which is VS actually. Makes sense, right? Okay. So what happens is we can express the VR naught as well as VS. So VR naught is actually just the current. So I will go through, right? It's split between the GM-VGS as well as R naught. So in this case, we can minus the GM-VGS part. But in this case, since it's actually going this way, right? And then we are taking here positive, here negative, then it's a plus lah. Let me see. Oh, it's negative VS, yeah. So negative because I already plug in so we negative GM-VGS. But because VGS equals to negative VS, I can plug inside already. So that's why it's plus GM-VS. Right, so the arrow is going downward lah, but it's VS here. It has to be VS. Yeah. Okay, because VG is equal to 0. Okay, R naught, right? Because it's the voltage across R naught plus VS. So later we need to find what is VS, right? Okay, so to find what is VS, okay, so in this case, what we have is we multiply out already. And for VS, actually, in this case, let's see. Yeah, so the current, right? Current for VS go through this RI and RS1. So you can see this RI and RS1, there's I test multiply, right? And I can see I actually kind of skipped that a bit lah. So it's just GMRO here plus 1, which is this 1 here. So it's GMRO plus 1. So VS is actually I test times RS1 parallel with RI. Can see, right? This is actually just I test and RO, which is just VRO. Right? And let me see. Yeah, VRO. Right, but VRO also got this GM, VGS, and RO, right? Which are separate out here. So this is part of the VRO. Plus 1 is the VS here. And the VS is expressed as this. I test times RS1 and parallel with R. Okay. And then I can cancel out the I test terms. And then I can get this expression. And we can finally calculate R out, which is just in parallel. And that's it lah. Just parallel with RD only. The R out prime parallel with RD only. That's all.
GMVS. The I test plus GMVS is but I test minus GMVGS, right?
Where?
This part is plus because of the VS, right?
Here +1. Yeah.
Yeah.
This VS is correspond to this one because this whole term, this thing is VS.
No, the first line, the I
This
test
one
plus
or this one?
the very top part.
Huh?
That
Here?
one.
Third one?
I test plus GMVS are not
This one? Ah?
up.
Here. Oh, why?
The plus is because of the VS, right?
Yeah, because of VS, yeah, because it's minus GMVGS, but
Yeah.
VGS is negative VS. That's why here become plus.
Yes. So I got confused on.
Okay. Can ah? And I think we are almost there already, right? You just need to find the input signal range. The input signal range, as we know, is from the formula like that. VGS is less than equals to 0.2 blah blah blah. We need to convert VGS to VI, which is a very simple voltage divider. But you can see our VGS here, and it's actually negative. It's just S here, VS, right? And VS is a voltage divider between, right, Ri and Rin. So you can see it's like that, right? VGS equals to negative Rin, blah blah blah. We can just, right, we can write the expression again, and then we multiply, right, the ratio, right? So we can get Vi on the left side. And then here is the multiplied value, and we just substitute the things that we found inside. And that's it. Yeah, and that's all for this question. You can see, right? This is actually what we kind of got just now, right? VGS equals to negative what? Rin, Ri, all this. Right. And then we want the VGS to convert. We want to convert the VGS to VI. Right. So there needs to be a ratio, right? So this one bring over, then this thing bring over, right? So that's why it's inverse, right? Like that. Multiply here. And then we know the values already. So we just multiply only. We just substitute and get the value. Then done. Okay? Happy? Okay, happy I can end already, right?
Can to speak already.
Okay.
This is on Japan.